So students, we will start the distance formula now, and see distance formula for this PDF already I have sent to you. And distance formula is basically used for finding the distance between two points whose coordinates are known. Now see, if I take a point P whose coordinates are x1 and y1, and I take a point Q whose coordinates are x2 and y2. Now, to find the distance between the points, I am connecting them with a line. The formula is PQ is equal to under root of y2 minus y1 whole square plus x2 minus x1 whole square. Okay. Now see, this formula we can also use, means derive, we kind of use it by plotting the points on the axis, coordinate axis. So I'm drawing the coordinate axis now. We've already been drawing it. I take the point P, and then its coordinates are x1 and y1. Then I'm taking the point Q. Its coordinates are x2 and y2. Okay. And I'm connecting them with a line. Now what I'll do is I'll connect the points with like this, drawing horizontally from P and vertically from Q, and draw perpendiculars from the points P and Q. Okay. And now what will be this distance? x2 minus x1, that is PR. And what will be QR? QR will be y2 minus y1. Okay. And now see, since there's a right angle triangle form, you can clearly know that it will be Pythagoras theorem used here. Okay. So that's how the formula comes of this distance formula. Okay. Now see what? The corollaries are given after this. It's the theory also. So corollaries are basically some results that are coming out of it. The first corollary says what? It says the distance of any point. Now see, the coordinates of origin are 0 and 0. So distance of any point from the origin is, if I take a point P as x and y, and I want to find out the distance of point P from origin, then how we can write that one? I can write as under root of x minus 0, because coordinates of origin is 0, 0, plus y minus 0 whole square. Then we can also write this as x minus x square plus y square. Okay. So this is the normal thing. You can always find the distance of a point from the origin, that will be under root of x square plus y square. Now the next thing that they are saying under remark column, and I will take as point number 2, it is the changing the order. If you're changing the order, like see, initially we're writing y2 minus y1 whole square plus x2 minus x1 whole square. If you're changing the order of the coordinates, I can write it as x1 minus x2 whole square plus y1 minus y2 whole square. So even if you are changing the order, the result remains the same. Okay. Make sure to make the radical sign properly, covering all the things. Here it is not covered. Okay. So if you're changing the order of the coordinates, then also your result is not changing. The result remains the same. Then third point talks about proving. See, we have already proved so many things, that a given quadrilateral is rhombus, square, rectangle, and already in midpoint theorem we have done. Okay. Now see, to prove that a given quadrilateral is a parallelogram, you are already knowing properties of parallelogram, that opposite sides are equal. Okay, we have done this in rectilinear figures also. Now what? if you have to prove that the given quadrilateral is a parallelogram, we have to prove what? You must have seen also in exercise 19.4, question 23 is given. Same thing they are asking. They are given the four coordinates they have given, and they have asked that tell that the quadrilateral is which type of quadrilateral. So four coordinates are given: AB, CD, EF, and GH. So you can get any time four coordinates, and accordingly you have to find out what the coordinate. You'll find the length of the sides, and then judge that which type of quadrilateral is formed. So from exercise 19.4 only. This question I have solved also in the PDF I have sent to you. Then you have some more questions also based on the same. Like if I talk about question number, second part, see first, you have to prove that a given figure is a rhombus. Rhombus property also you are knowing, all the sides are equal. That only will show. And for parallelogram the property is opposite sides are equal. For rhombus what it will be? All the sides are equal. All the sides equal means find the length of all the sides and show them they are equal. That's how we do it. Then third part. Third part is proving that a given figure is what? A rectangle. So how we will do this one? We'll show that the opposite sides are equal and diagonals are also equal, or show that opposite sides are equal and one angle is 90 degree. Okay, so these all properties you must remember. And fourth is proving a square. Show that all the sides are equal and diagonals are also equal, and or show that all the sides are equal and one angle is 90 degree. We have similar questions in this, children, in the exercise also. I think so question number 21 it is there like that. Question 23 was regarding finding which type of quadrilateral it is. Question 21 is there. Now you see later on, this was all the theory. Section formula also is there, not here. In class 10th you will have to study about section formula, which talks about how a given coordinate will divide the line, in which ratio. Suppose you are having points, coordinates are there P and Q, and there is a point R. Now in what ratio M is to N it will divide the given line segment. Okay, not required here as of now, but so that is why the extension of distance formula is distance in section formula. That is the proper topic. Okay, now I'm coming to the exercise 19.4 questions discussion. All this theory is this much only. Now children, starting with the question from exercise 19.4, I am taking the first question here now. Okay, let me take the page number first. This is the PDF, all that I have, the same PDF as I have sent to you. Okay, I am taking the first question, zooming it in further. Fine. Now you see here in this question what is given. We have got coordinates x1 equal to 2, y1 equal to 3, x2 equal to 4, and y1 equal to 1. Now what? See here we are having this formula, and the distance formula can be used here to find the distance between the points 2, 3 and 4, 1. We are having this formula, and accordingly you substitute the values of y2 minus y1 whole square plus x2 minus x1 whole square, and then you get the value like that. It will come what? 4 plus 4, and that is under root of 8 or 4 root 2 or 2 root 2 units. Okay. Now this second question, similar pattern, nothing new in this. Third also distance formula only has to be used, so nothing new has to be told in this. I am moving to the next question, taking question number, let's choosing the correct page number. It is more oriented when we are using this IFP panel. Yes, question number 5 I am taking, children, now. What does question number 5 say? Question number 5 says find the point on x-axis which is equidistant from the points 2 comma minus 5 and minus 2 comma 9. Okay, now see, already you are knowing from your knowledge that this your points on the x-axis, if the point lies on x-axis, its y-coordinate will be 0. Now if you use the distance formula here, see here the coordinates a and b already given, and the middle point I am taking as c. So coordinates of middle point will be what? B comma 0. See here, a is given what? 2 comma minus 5, and b is given what? Minus 2 comma 9. So if the point C has to be equidistant, it has to be what? Equal from both A and B. Yes or no? Then what will happen? See, we have used the formula, we have substituted the values also, and see, we will find AC equal to BC. Means we will put AC equal to BC because C is equidistant from A and B both. So AC and BC both will be equal. In that case, we will use the distance formula using the values. And what you will get here is under root of B minus 2 whole square plus 0 plus 5 whole square under root equal to b plus 2 whole square plus minus 9 whole square. Clear? And accordingly you get a linear equation. The squares will be cancelled on both the sides. See, b square plus 4 minus 4b plus 25 equal to b square plus 4 minus 4b plus 81. And this b square on the left side and right side both will be cancelled. So what will happen then? You will get 29 minus 4b equal to 85 plus 4b. Okay, and see, accordingly you get the value of b as what? Minus 7. Now I am taking the next question, which is question number, page numbers are a little bit altered. Okay, it is not in the same sequence as we are knowing it to be. So let me see. Next question has to be question number 8. Okay, question number 8. I put a star also on this question because little bit of thing is required here. This is not a direct question of finding out distance, but some more details are given here. Question number 8 says find the relation between x and y such that the point xy is equidistant. So equidistant, again you understand, I guess, that the distance of AC and BC will be equal. So we have done this thing, nothing new in this, but again we have to assume that the points of C is what? X comma y. We have to not assume, it's given also xy. So we'll put the values there and put in the proper formula and find accordingly the value of the distance. Let's see here also, like the previous question only, it will be cancelled. X can be cancelled on both the sides. So in this equation you see what? X square, x minus 7 whole square plus y minus 1 whole square equal to what? 3 minus x whole square plus 5 minus y whole square, and we are doing the squaring both the sides, so it will come in like again the same way. And again x square y square on left side and right side gets cancelled, and we get the equation like this. Okay, so you get again a linear equation, only you get in x and y, and when you solve that, it becomes what? Minus x plus y plus 2 equal to 0, and x equal to what? Y plus 2, or x minus y equal to 2. Now ninth, already you see, ninth you are doing what the ninth question says. Ninth is about again finding equidistant part only. So ninth is nothing different. I am taking the question number 10th now. What does question number 10th say? Question number 10th is telling that, again a hint is given for the same question, so nothing new in this question also. Question number 10th, points are given, they are on the circle. So if points are there on the circle and the distance is, the points are on circle, that means they are on the circumference. So what will happen then? It will be radii. So these points that are given here, A and B, will form the radii. So the radii are equal. So that's why what will happen? We will say AC equal to what? BC, and C is the center. Now what? You will put the values there again. AC, finding the value of AC by distance formula, substitute them again, and value of x has to be found out. So x value you will find out by how? Using the distance formula. So AC value you can calculate, similarly BC value you will calculate and substitute that. C you will find here under root of, so this way you can find out the value of x also. Next, I'm taking up question number 14. Sorry. Sorry. 14th question is a bit different question, children. Why? Because it's a question based on collinear part. Collinear part means this you have to prove that these given points are collinear. That is, they lie in the same straight line. So if the points have to lie on the same straight line, what will happen? The distance, if you add, like if you say A, B, C are collinear, then AB plus BC should be equal to what? AC. And I remember I had told in the class also that if at all 3 points are to be collinear, then the distance of the individual points between the means like AB you add and BC you add them, and if that distance comes out to be equal to AC, that is the length of the ends, if you add, find the distance. Now that question has come again. Finding that PDF part was an issue. Numbering is there but detailing is too much, so that's why it has come like this. Okay, this is question number 18. Okay, so 18th question says what? 18th question is also regarding that only, proving that a given figure is a isosceles right angle triangle. Again, these all things isosceles you can prove by proving the sides are equal. Okay. Now see here, this is question number 14. Already it's done, I guess. So it will be like this only based on collinearity part. So when you are finding the length of sides for question number 18. So for question 18, what you will do basically, your question 18 will do is that it is given here to prove that isosceles right angle triangle. So for isosceles right angle triangle, what you will do? Prove that first it is isosceles, that means length of two sides will be equal. So see, find the length of AB using distance formula, then find the length of BC and AC also. You find the length of AC and BC, you find that AB and BC, you find that both are equal. So if two sides are equal, what you can say? That their triangle is isosceles. But for right angle triangle, isosceles right angle triangle, Pythagoras theorem has to be proved. That means you find the length of hypotenuse also, that is AC. So if the length of hypotenuse you find out and length of other two sides you find out and prove the Pythagoras theorem for it, then you can prove that this is a right angle triangle. That means that is the AC square equal to what? AB square plus BC square. So if that is proved, you can clearly say that this is also a isosceles right angle triangle. So see, there are two parts in this question. One part was what? Prove that the triangle is isosceles, other is what? Right angle. So for isosceles, again using distance formula, we have proved that the length of sides are equal. And for right angle triangle, we have proved that the Pythagoras theorem is valid. That means Pythagoras theorem is satisfied using that part. So again, for these all questions, children, you need to draw the diagram. Diagram you draw and label the make the coordinates. Don't do it randomly. See, I have done in a very organized way in the PDF. It could be possible you do it much better than me. But again, I am giving you a standard method. You have to mention also that what you will use to prove. Proving questions are not, this is not like congruency proving or proving in the rectilinear figure type that questions are there. But again, this is simple thing. How to prove that a triangle is isosceles? You are knowing clearly that if a triangle has to be isosceles, the sides have to be equal. Two sides have to be equal. And for a triangle to be right angled, what you will do? You have to prove that the triangles should satisfy the Pythagoras theorem. And Pythagoras theorem itself states what? That for a right angled triangle, the square of the hypotenuse is equal to what? The sum of the squares of other two sides. If that is true, we can say that the given triangle is what? Right angled triangle. Okay. And see, based on this only 18th question like that, so many questions are there afterwards. After 18th, you find so many questions. Like you see, question number 17th is there, that you have to show that it is equilateral triangle. For equilateral triangle, what you will do? For equilateral triangle, again find out the length of the sides, again using the distance formula. So when you find the length of sides using distance formula, you will have the length of all three sides, and if the length of all the three sides comes to be equal, then you say what? That it is a equilateral triangle. Similarly, if you see question number 19, they are just now saying for question number 19, the points are given and the points are vertices of a right angle triangle. Now they are showing that, telling also that the figure is a right angle triangle. Now, if they are confirming that it is right angle triangle, it means what? It means that you can use the Pythagoras theorem here. Only find the length of sides, and see here it is asked to find the value of A. A is one of the coordinates of the vertices. It is similar. Question number 19 is again similar to that question where we have to find out on that circle one that we are doing. Question number 10th question, where the points were on the circumference of the circle, and there also the value of a coordinate was to be found out. Since the points are the circumference of circle, in question number 10th, what were you doing there? There we are saying that since the points are on the circumference, AC equal to BC. That is from the center. The coordinates of center is given and the coordinates of the points on the circumference is given. So we will prove that AC equal to BC. So in that case, what will happen? You will prove that they are equal, and once you prove equal, you will find a equation. Okay, so that way you can do it in this side. Now, let's see what the next question is. I am taking up the next question now. That is question number 24, if I am not wrong. What does question number 24 say, children? Question number 24 talks about, let me find the first correct page number for it. Children, please ensure you complete all these questions in your class or copy. I understand it's tough time for you, so many things are got, you are getting, so many PDFs you are getting, videos you are getting, but again, it's the time to do it. Now, question number 24. I am reading out the question number 24. That is the last question of this exercise. It reads, find the coordinates of the circumcenter of the triangle whose vertices are 8, 6, 8, -2 and 2, -2. Also find the circumradius. Now, if you remember your knowledge of chapter 10, the circumcenter is what? Circumcircle is what? So this you find out that circle is a circle which circumscribe the triangle. Okay, and the center of this will be what? Called as, so we have used again here the distance formula only, but I have done the square of it. Okay, distance formula how I used, because see, if A, B, C are the points on the circle, again from the circumcenter they will be called as radii only, so they will be radii. So radii will be equal, but I am not taking radii to be equal because I have taken square here. If I take radii to be equal, all the things will get cancelled, so it will take square. So if the lengths are equal, their squares also will be accordingly equal. So I have taken here what? AO, BO and CO are what? The length of radii, and coordinates of A, B, C are known. I have assumed that the coordinates of circumcenter be x, y. Now, AO equal to BO and BO equal to CO. In that case, what will happen? So, see next page what is given here. AO equal to BO and BO equal to CO. So, once I will do AO equal to BO, and then I will do what? I will do BO equal to CO. In fact, square of them. Again, don't go for AO equal to BO and BO equal to CO. You have to do square. So we'll say AO square equal to BO square, and see here accordingly I have put the values there. The distance formula I have used here, and finding the value of x. So when you equate two things, you get one value, and then you find out this. Similarly, you can say for BO equal to CO also you do, and then you find the value of x in that case. Square. Sorry. So then after finding the value of x and y, you substitute in any of those equations for AO, BO or CO, and you get what? The value of circumradius. I hope it is clear to all. So there were 24 questions in this exercise, and we have tried so many questions. Again, you see, so if you are substituting the values properly of x and y, if your x and y is not wrong, you can get it this thing correctly done. Okay. Now, so see here, the question is also about finding the circumradius. So don't stop after finding the circumcenter only. Circumcenter is 5, 2, and you have to just equate the squares here. Now this is over now. Now I will also continue in the same lecture about theorems on area. Okay, so let us start theorems on area. This is the, I will discuss the theory portion of it, children, which is required, much required. This is the second last chapter we are doing here, and this is your chapter number 14. Now see theorems on area. First I will talk about theorems on area. You see, if you open the book also, your page number 295, it is given there, theorems on area. First I will write about planar figures. What is a planar region? Planar region. Okay, what is planar region, children? So planar region, if I write, part of the plane enclosed by a simple closed curve is called as a planar region. So in a plane, if you are making a simple closed curve, then it will be called as what? Planar region. Let me write, part of a plane enclosed by simple closed curve. Okay, curve. Okay, and see also you are knowing many things about area also. Area you have calculated so many places. If I talk about area, you know area is always calculated in square units, meter square, centimeter square. Okay, like you have calculated area also in coordinate also many places. So that is area is calculated in square units. So this chapter is about many relations you will understand by the regarding the parallelograms and all. Parallelograms and triangles, parallelograms and rectangles. So first thing I'm writing is exams on area. So exams on area, what are those? I'm writing first is, in exams on area, the first thing is congruence area exam. What it is? Congruence area exam. Okay children, congruence area exam. What does it say? It is mentions if two figures are congruent. See, congruency was studied also in chapter 10 also. So many ways to prove congruency. So if two figures are congruent, then the area enclosed by these figures is equal. So if they are congruent, area will be equal. I have told you also again when I was discussing about similarity and area, similarity and congruence. I told congruence means areas are equal, corresponding sides are equal, corresponding angles are equal. But similarity means ratio of sides is equal. Okay. So if two triangles are congruent, two figures are congruent, not only triangles, two figures are congruent, their areas will be equal. Next is addition or area addition exam. No problem with that. I can write addition area exam or area addition exam. Now what does it say? It talks about a planar region R. It says if a planar region R, in fact I am not talking this way, I am talking about if an area if a planar region R. So in the planar region there are two more regions which are non-overlapping, and this non-overlapping condition is very important children. So if a planar region consists of two non-overlapping planar regions. If a planar region consists of two non-overlapping planar regions, non-overlapping planar regions, then area of, so this non-overlapping part is very important. Then so the non-overlapping regions are R1 and R2. We can say that non-overlapping regions are R1 R2. Then area of region R, which is consisting those two non-overlapping regions, will be equal to area of region R1 plus region R2, or area of R1 plus R2. That's how we are writing it. Okay. So you can add the areas if there are what? If the regions are, if the regions are non-overlapping and they are lying in the same planar region. Next, equal areas, equal figures, sorry. Equal figures. Now see, what does it mention? Two figures are called. Let me write the statement. Two figures are called or two figures are said to be having equal area. They are said to be equal. Figures are said to be equal if and only if. That means this has to be satisfied if and only if. Only one condition. That is, if and only if they have equal area or area equal. Okay. Now what? Theorems in area now we are studying. First theorem, theorem 14.1. Okay, what does it say? Theorem 14.1 says a diagonal of a parallelogram divides it into two triangles of equal areas. Now, now you see, what does it mean? It means that a diagonal of parallelogram divides the parallelogram to two triangles of equal areas. And see again, into two triangles of equal areas. Okay, and you have done similar thing for rectangle also, yes or no? That the diagonal of the rectangle divides it into two equal parts. Now see, I am drawing it, the proof part. I am taking a parallelogram and I have drawn a diagonal also. Let us name it A, B, C and D, and diagonal is AC. Then see here, these are parallel sides, opposite sides are parallel in diagonal in a parallelogram. AB equal to BC. In these two triangles, we are taking the triangles AB equal to BC, then BC equal to AD. Okay, what is the reason for this to being equal? They are opposite sides of a parallelogram. We are proving congruence basically in these two triangles, because for proving by proving congruence only we can say that the areas are equal. then only this theorem is proved. And what? AC equal to AC. Which criteria? SSS criteria. Side, side, side. I hope it is clear to all now. So first theorem is proved now. Next is theorem 14.2. What does it say? And see, similar to theorem 14.2 we will get later also. Let me write the statement first. It says parallelograms on same base. Parallelograms on same base and between the same parallel lines parallelograms on same base and between the same parallel lines are equal in area. Are equal in area. Clear to all? So that's the statement here. Now I am drawing and showing you that how these are there. Let me draw a parallelogram. This is our first parallelogram. Then I will draw the second parallelogram having the base same. A, B, and I'll do the second parallelogram also. I'm extending here. I have drawn dotted here, but again you can draw continuous also. This continuous only has to be drawn. This is just to make you understand that there are two parallelograms on the same base, AB, and this is E, then this is C, then there is F, and then D. The last vertex is D. Okay, clear to all? Now, the angles are equal. Corresponding angles, then these angles are also equal again. Okay. So you can see here the triangle ADF and BCE are congruent. By which criteria? They are by AAS criteria, they are congruent. Okay. You can see the congruence criteria also. Angle, side. Which side is common here? AD and BC. No, not common, equal. So see, triangle ADF is congruent to triangle BCE. The congruence, I think so, should not be a problem now. BCE. Now, after proving congruence, the triangles will have equal area. And then to that we are adding something. By ASA criteria, you already knowing. Sorry, AAS criteria. By AAS criteria, the triangles are congruent. Now, area of triangle ADF plus, now see, area of triangle ADF equal to area of triangle BCE. This we can say already, obviously by, we can say it by the congruence part. The triangles are congruent, the areas will be equal of the triangles. Then next what? We can add the area of the quadrilateral in both of them. So if you add the area of same quadrilateral to both of them, the result remains unchanged. We have done similar questions where something was equal, and to those equal things, if you are adding the same thing on left hand side and right hand side, the result doesn't change. That's why I am saying AR. AR dot means area only, short form of writing. Area of triangle ADF plus area of parallelogram ABEF. It should be not parallelogram, it should be quadrilateral only. Equal to area of triangle BCF plus area of quadrilateral ABCF. So just I've written parallelogram, but it should be quadrilateral only, because same we are adding area of quadrilateral ABEF or ABCF. We are adding both the sides. So if you are adding the area of quadrilateral ABCF both the sides, it will be still equal, and then it will be, we can say that area of the parallelogram ABC is equal to area of parallelogram ABEF. That's how the proof of theorem 14.2 is. Now see the corollaries. Corollaries are basically conclusions drawn from this. Corollary 1. What does it say? It says a parallelogram and a parallelogram and a rectangle a parallelogram and a rectangle on the same base and between same parallels. So whether you say between same parallels or whether you say between same parallel lines, meaning is same. Between same parallel, between same parallels are equal in area. Clear? That's why the chapter is theorems on area, because of area equivalence. Now what is corollary 2? Already you are knowing. So see, by this corollary we are proving, by this theorem we are proving, we are knowing so many formulas that we have already learnt, that we have been using also. We can prove them also. So what is given here? It is corollary is area of parallelogram. Area of parallelogram is equal to what? You are already knowing this formula, base into height. Area of parallelogram is base into height. Then next we are having corollary 3. Corollary 3. Corollary 3. Which states that parallelogram with equal bases and between the same parallels are equal in area. What it is? Parallelograms with equal bases, equal bases and between the same parallels between the same parallels are equal in area. Clear to all? So these 3 corollaries are there from for theorem number 14.2. Clear to all? Now next is theorem 14.3. Theorem 14.3 says what? It says parallelograms on same base and having equal areas and having on same base and having parallelograms on same base and having equal areas lie between same parallel lines. So parallel lines or parallels meaning is same. Again you can see if the parallelograms are lying on same base and between same parallels, area will be the area is equal. So if they are lying on same base and area is equal, they will lie between same parallels. There are three things in this. One is same base, other is equal area, and third is between same parallels. So here area is equal and they are on the same base. So third thing is what? They will be between same parallels. Now corollary 1 is what? Corollary 1 says parallelograms on equal bases and having equal areas. Now this is something new of equivalence of altitudes also, and see the word is used corresponding altitudes. Parallelograms on equal base or same base and having equal areas. So if base is same, area is equal. Now you cannot say this thing that they lie between same parallel lines. Here we say they are having like that. So what will happen? They will have equal corresponding. The word corresponding is important here. Altitudes. If you have learned the questions where the altitude length was changing depending on the shorter side or the longer side, you have done that question also. Yes or no? Now next, corollary 2. Corollary 2. What does corollary 2 say? Parallelograms on equal bases. Parallelograms on equal bases and having parallelograms on equal bases and having equal areas. So they are lying on the same base and having equal areas. Will be between same parallel lines. So that is corollary 2. Told you there are three parameters. One is on same base, other is equal area, and third is between same parallels. So if two things are there, third thing will automatically come. It could be for parallelograms, it could be for rectangles also. And one was saying about equality of altitudes. Corresponding altitudes will be equal. That's how it goes. Next is theorem 14.4. And see, in between there are converse of theorems also that are also true. Okay. You already know when forward is true, the reverse also is true. Now what is theorem 14.4? It says area of triangle is half that of a parallelogram, half that of a parallelogram on the same base and between the same parallel lines between the same parallel lines. So whatever triangle will come, that will be sharing the base. Sharing means the same base as that of a parallelogram. The area of the triangle will be what? Half of that of the parallelogram. We have questions also based on this. Okay, but only the condition is triangle should be between the same parallels of the parallelogram and it should be on the same base. Then the area of triangle equal to what? Half of the area of parallelogram. See, I am drawing the parallelogram first, and see, triangle is drawn like this. If the base is AB, C, D, E, can I say that triangle ABC, triangle AB, area of triangle ABD, so triangle ABD is on the same base AB, so area of triangle ABD equal to what? Half of area of parallelogram ABCF. So ABCE, ABCE. Only important condition is what? Making the triangle and parallelogram sharing the same base, and if it is lying between the same parallels, then only area will be. Now corollary 1. Corollary 1, again I told you, with theorems on area, many corollaries are which are conclusions from the theorem you will be knowing, and this is very simple also, nothing new in this. First is what? That you are already knowing. Area of triangle is what? Half into base into height. So like we had given one formula with the previous corollary also, not previous, 14.2, that area of parallelogram is half is base into height. Similarly with the corollary 14.4, the theorem 14.4, one corollary comes, that is area of triangle is half into base into height, and we have been using this formula, yes or no? Then corollary 2 states what? Corollary 2 is important, I made a star on this intentionally. What? A median of a triangle. We have proved so many questions in congruence where a median was drawn and you have proved those two triangles are congruent. Inside the triangle only one median was drawn. So a median of a triangle divides it into two triangles. Divides it into two triangles of equal areas. This was corollary 2. I put a star intentionally. Corollary 3 also is very simple. Again it is a formula only. What is that? Area of trapezium. You know, again it is what? Half into sum of parallel sides into height. Okay. So 3 formulas we have encountered till now. One is area of parallelogram as base into height, then area of triangle is half into base into height, then area of trapezium is half into sum of parallel sides into height. Nothing new in this. But previous corollary was important, that median dividing into two equal triangles of two equal areas. And then one was where altitudes were equal. The corollary of theorem 14.3. Now next theorem I am taking, theorem 14.5. See, theorem 14.5 is just like theorem number 14.2, yes or no? In that case, we are saying for parallelograms on same base and between same parallels. Now we are saying what? Triangles on the same base and between same parallels. So theorem 14.5 and 14.2 are exactly same, only the figure is different. Means in 14.2 we are talking about parallelograms, and in 14.5 we are talking about triangles. So triangles on same base or equal base. Same base or equal bases and between same parallels are equal in area. So again, area of triangles should be equal provided they share the same base. Again, you will get some questions for calculations also. Next, I'm drawing the figure for it. See how you visualize two triangles. One base is there with this one triangle we have drawn. Now another triangle. See, and see both are lying between the same parallel lines also. So they are between same parallels and they are sharing the same base. So the triangle is ABC. First triangle is ABC. Other one is what? This is D. Between the same parallels they are, or same parallel lines. This is E. So what you can say? Area of triangle ABC is equal to area of triangle BCD, triangle BCD. Okay. Now see, next is theorem 14.6. Theorem 14.6. What does it say? Theorem 14.6 says triangles on the same base. It is just like theorem 14.5 only. I told you initially also that there are three parameters: parallelograms or triangles, same base, same parallels and equal area. So here what is here? Here it is triangles on the same base or equal base and having equal areas will lie between the same parallels. Okay. So they will be having equal base and having equal areas. So if they are having equal areas and they are on the same base, then what? Third thing remains, they will be the same parallels. Did we say the same thing for rectangle also? No, we said in the for parallelogram and rectangle. That was corollary 1 of theorem 14.2. Okay, parallel lines. Now corollary 1 for theorem 14.6. What is that? Corollary 1 is again the equality of altitudes it is. Then corollary 2 is about ratio of the areas. And corollary 3 also about ratio of the areas. Okay, corollary 3. These three corollaries are from theorem number 14.6 only. Corollary 1. What does it say? It says triangles on same base. This delta symbol is for triangle also, so I am drawing it that way only. So triangles on same base or equal bases and between same parallels parallels is not mentioned here, sorry. Triangles on same base and having equal areas will have equal altitudes. When did we last talk about equal altitudes? We had talked about equal altitudes in the theorem now see it is if two triangles lie between the same parallels, corollary 2 it is, that is equal altitudes. So altitudes are equal, what you can say? Ratio of areas of those triangles is equal to what? Ratio of the base. So this is talking about ratio of area equal to ratio of bases. Clear? Then corollary 3. If two triangles have equal bases, now if base is equal, then what will happen? Then ratio of area equal to what? Ratio of altitudes. Okay, so again thing has come. Triangles are there, area equal, between same parallels, then what will happen? If altitudes are equal, then ratio of base will be what? Ratio of areas. And if bases are equal, then ratio of area equal to what? Ratio of altitudes. So corollary 2 and 3 are very similar. Only ratio of base in the corollary 2 and ratio of altitudes in corollary number 3.